So immediately from our past video, let's go ahead and combine the two terms that we see up above here. And what we get when you combine like terms, y of s becomes, in the numerator, 5 plus 12 times s squared minus s cubed. All right. In the denominator, we're going to end up with s squared times s minus 9 times s minus 1. Okay? And then if we use partial fraction decomposition to transform this rational expression, what we end up with is the following. We get y of s equals a, some unknown a over s, plus some unknown b. It's a b. Let me go ahead and make that more clear. B over s squared, okay, plus c divided by s minus 9, okay, plus d all divided by s minus 1. So how did I know that? Well, generally speaking, when you have ordered powers, you need a fraction for every single power. So in this case, when you have a power of 2, you need two increasing orders. So you have s to the first, then s squared. And then again, these are both to the first power, so you just list them down one time, s minus 9 to s minus 1. There's a whole literature on partial fraction decomposition for you guys to look up. There's just 4 simple rules. I would ask you to go ahead and review those as soon as you can and as you need to. This will likely show up on your final exam, so this will be important for you guys to brush up on in preparation for that. Okay? So now that we have this all set up, now we have to solve for each of those unknown coefficients, a, b, c, and d. All right, so setting the numerators equal in the way that we had it before, because we're saying and claiming that this expression in its partial fraction decomposition is equal to this expression, right? So we can set the numerators equal to one another, and so this is what we end up getting. As a result of that, we end up having this result, 5 plus 12 times s squared minus s cubed, okay, is going to all be set equal to a times s, all right, times s minus 9, after you collect all the terms from the denominator, plus b times s minus 9, okay, times s minus 1, all right, plus cs squared, okay, times s minus 1, plus ds squared times s minus 9. This is what you end up with, okay? So this expression is equal to this expression, all right? So we're going to pick appropriate values of s and solve for the constants, all right? So where s equals 0, okay, how do I know that? Because s being 0 would make a be 0, just like s being 9 would make this term be 0, and s being 1 would also make that term be benign or useless. Now, there are a few others that we can try to use, and I'll explain them as we go. But first, let's do s equals 0. So what this implies is we end up with 5 equals 9 times b. Okay, that's what we end up with. And so that implies that the term b equals 5/9. Okay, so what about the case where s equals 1? When s equals 1, we end up with 16 is equal to negative 8 times d. Okay, that's what we end up with when s is equal to 1. So this implies